So I think in the last video I was talking about a way that you can figure out the domain of a logarithm without having to think about the graph and the horizontal shift, because it won't always be quite that simple. If you remember when we were doing square roots, you could just take whatever was under the square root, set it greater than or equal to 0, solve the inequality, and you get the domain. Does that all sound familiar? All right, so you can do the same thing with the argument to the logarithm. That's what this thing is back here. This thing right here is called an argument. So what I can do is I could say, okay, x plus 2 is greater than 0, so x has to be greater than -2, like that. So for instance, if I gave you something like this, did I go too fast? Story is there was just a lot of crap.
Yeah.
Okay. So anyway, let's say that we had so if I wanted to find the domain, first of all, the range would be from negative infinity to positive infinity on this. But if I wanted to find the domain, I would take the argument x minus 1 squared and set it greater than 0. Now, if that's not linear, which that isn't, you need to make sure you do it with the number line like I showed you at the end of chapter 3. Where is that equal to 0? Where's that 0? At 1. And then test your regions. If I plug in a number from over here, say 0, 0 minus 1 is negative, but when I square it, it'll be positive. I want that. And if I pick another number, 2, 2 minus 1 is positive, and when I square it, it'll still be positive. So then your domain would be negative infinity to 1 union 1 to infinity. And obviously, if this were some other polynomial, you would just try to factor it and then do the same sort of thing. Sound good? All right, so we talked about domain, we talked about transformations. Let's talk about common log. This is the kind that you find out in the woods. Not really. Common log is log base 10. The reason why that's considered to be common log is because we use a base 10 system. The decimal system. And so what you have to understand is the notation we use for common log, we don't put the base there. So if the base is missing, it's understood to be base 10. So this and this mean the exact same thing. This would be something I'd expect you to be able to do without a calculator. The log of 1,000. What question would I have to ask myself to figure that out? What's the base understood to be? 10. So you're literally saying 10 to what power is 1,000? No. 10 times 10 is 100. So what power of 10 is 1,000? No. 3. 10 times 10 is 100. Times 10 is 1,000. Oh, well, I didn't hear that. I'm sorry. All I heard was 100. My bad. Oh, I think I thought you said 2. Oh, okay. I feel bad now. I fail at life. All right. Now.
Hey, at least I said something like that. See, we've had like the same thing, so I quit laughing at me.
You know that's on video now.
I don't care. Everybody knows.
Now, I don't know about you, but I'm not sure what power of 10 gives me 5 over 2. But your calculator should have a log button on it. So your calculator can compute log base 10. So if I do 5 divided by 2, that'll be 2.5. And then I take the log of it, that comes out to be approximately 0.398. Now, here's a point I want to make. What if I want to do log of 5 divided by log of 2? You think that'll come out the same? That's probably a pretty good guess. Let's find out. So if I take the log of 5 and divide it by the log of 2, that comes out to be 2.322. Decidedly not the same. So, the percent of adult height by a boy X years old is f of x equals 29 plus 48.8 log of x plus 1. Clearly they did some statistical analysis to come up with this. Somebody did something somewhere to figure that out. So I'd like to know what the percent of adult height would be at age 8. How would I compute that? Okay, so, yeah, we would do f of 8. Would everybody be okay if I just wrote log of 9 instead of log of 8 plus 1? Because you got to plug it in right there, right? Now, when I go to do my calculator, I'm going to do the log of 9 first on this one. A lot of you can just type it in as is. But on this type of calculator, I'm going to do the log of 9 times 48.8 plus 29. And that comes out to be roughly 76. So according to this model, at age 8, you're 3/4 of your adult height. I'm not sure I believe that, but just go with it. Now you might be asking yourself where all this log stuff comes into play. I'm going to quickly mention it before I have to render this video, and then we're going to talk about natural log. That's also a log that you find out in the woods. But anyway, what do they use to measure earthquake intensity? Not like the device, but what do they quote earthquake intensity on? Like this is the magnitude, which is on the Richter scale, right? The Richter scale is actually logarithmic. So the number on the Richter scale is given by the earthquake intensity. Whoops. The log of the earthquake intensity divided by the intensity of what's considered to be as level 0 earthquake. So they basically picked an arbitrary value to be level 0. And then when they do this division and take the log, that becomes your number on the Richter scale. Which means that if you go up by a level of 1 on the Richter scale, the earthquake is 10 times more powerful. If you go up 2 on the Richter scale, that's 100 times more powerful. If you go up 3, that'd be 1,000 times more powerful. That's why if you go from like a 4.5 to a 7.5, the 7.5 is 1,000 times more powerful than the 4.5. Does that make sense? Also, how do you measure acidity of something? pH. pH uses logs as well, just has a minus sign in there. So pH is the negative log of the concentration of hydronium or hydrogen ions in solution. And because of the minus sign, that means the lower you go, the more powerful it is. The reason why there's a minus there is because usually this is times 10 to the minus something. Also, loudness of sounds, decibels. If you take the prefix deci off there, which means like a tenth, you know, like centimeters or millimeters, well, deci is one of those prefixes. And if you look at the unit bell, that one is also logarithmic, as in if you go up a certain number, it's 10 times more powerful